Scientific notation operations. I like the sound of that. It's kind of cool sounding. Anyway, you're going to have a lot of writing to do. You want to copy the stuff down that's on the screen. You don't have to do it exactly, but you want to definitely make sure what you're doing here because you're going to be number crunching for a long time when you come to school. So, what I want you to do is look at this sample problem here. When you're adding, subtracting numbers in scientific notation, your exponent or your order of magnitude needs to be the same. When you look at this, you see that these are not the same. See? I wonder if I could change the size of that. Oh, I can. All right. So what you would do in order to make these the same is you could take the decimal here and move it. See how we moved it to that spot? When you move it, that changes this exponent. It increases it by 1 when you move to the left. So now what you can do is you can add the numbers and then you keep the 10 to the third. So pretty simple, right? Let's try some samples. All right, here I have a sample. I have 1.3 times 10 to the fifth plus 2.3 times 10 to the fourth. So what I'm going to do first, I'm going to take this fifth and I'm going to decrease it to the fourth. The way that I do that is I'm going to take this decimal and move it to the right so that it decreases by 1. Now that's going to make my answer a little bit interesting, which you'll see in just a second, okay? And this is 2.3 times 10 to the fourth. Now my order of magnitude is the same, so I could take 13 plus 2.3, and I can keep the times 10 to the fourth. This is 15.3 then times 10 to the fourth. So you're looking at it and say, okay, what is the problem? Can you tell me what the problem with this is? You should. You should be able to say, oh, that's not in scientific notation because the number out in front, it's not between a 1 and a 9. So what do we have to do? We have to move this decimal 1 place to the left. When we do that, the exponent will increase by 1. So we have 1.53 times 10 to the fifth. That is my final answer. Now, if I took the same problem, 1.3 times 10 to the fifth, plus 2.3 times 10 to the fourth, that's a 4, and rather than taking the 10 to the fifth and decreasing it, I'm going to take 10 to the fourth and increase it. To do that, I'm going to move the decimal 1 place to the left. So then what I have is 1.3 times 10 to the fifth plus 0.23 times 10 to the fifth. Then I can add the numbers, 0.23, and keep, the 10 to the fifth. 1.3 plus 2.3 is 1.53 times 10 to the fifth. Oh my gosh, would you look at it? It works! Of course it works. The idea is you follow the rules, you will end up with the correct answer. However, you may initially, I don't like that green, let me go back to my yellow. You may end up with a number that is not in scientific notation. Well, that's easy enough to fix. All right, let's move on to multiplication. For multiplication, here, when they are multiplied, your order of magnitude does not matter. What you would do is you simply multiply the numbers, and then you follow your rules for exponents. We have bases that are the same to different powers. So 10 to the third times 10 to the fourth is equal to the 10 to the third, or 3 plus 4, which is 10 to the seventh. I think that's one of the easier ones personally. Let's try a sample. You pause the video if you're still writing this though, because I'm moving on. Here's my sample. Alright, so the rule says that you take your numbers, 2.3, and you can multiply them times 8.6, and this will be then times 10 to the 5 plus negative 12. Well, I don't expect you to do this mentally. Okay, you can do this in your calculator. And you end up then with 19.78 times 10 to the negative 7. Now, the problem is we are not in scientific notation. This has to move 1 to the left. So this will become 1.978 times 10. And what happens to this? It increases. Oh, but you're like, that does not an increase. It is. Okay, 1.978 times 10 to the negative 6. Moving on. Division. I like division. Again, guys, it's following your rules. So you divide the numbers, and then you have same bases. You subtract their exponents. So I would have 9.6 divided by 1.6, and then I have 10 to the 7 minus 4. Let's try a sample. Here, for this sample problem, I have 7.2 times 10 to the 7th divided by 3.6 times 10 to the 3rd. This is the same thing as 7.2 divided by 3.6. And this is going to be times 10 to the 7 minus 3. I set it up like this so it wouldn't confuse, or I wanted to show you one like this so you wouldn't be confused if you saw it in your notes, because you know how to do it in a fraction. 7.2 divided by 3.6 is 2 times 10 to the 4th. Pretty easy, right? I think so. Goodbye, my friends, goodbye.